Good afternoon, guys. I'm Emmanuel Sumo, and today we are going to learn a little bit about 3D printing. So, what is 3D printing? Do you have any idea about 3D printing? Okay, to understand what is 3D printing, let's look at the 2D printing, like the printer for the one that we use to print on paper is 2D printing because on two axes, S and Z, S and Y. So that one is just working on a surface on two axes, S and Y, not on the Z axis. That is a 2D printing process. But now the 3D printing is like when we are trying to print an object on the three axes, X, Y, and Z. And for 3D printer, we can use various type of material such as PLA, ABS, and many other. So for 3D printer, we can use various type of materials such as PLA, ABS, TPU, depending on the output characteristic of your material, like the object, the strength that you would like to have. You will select a specific type of filament and also the elasticity of the object that you want to print. You will select a specific type of material, whether PLA, ABS, TPU, or PET. So depending on the object that you would like to have at the end, you will select the type of material. For that one, we are going to talk about it maybe later. Now, the history of 3D printer is not the actual technology. It has been invented in 1984 by Charles Lee Hall, and it became popular in the recent year, like in the 20th century, but it has been invented a long time ago. So, how does 3D printer work? So, for 3D printer, for 3D printer to work, it's kind of tricky. You need to first of all know how to design the part. So CAD design, computer assisted design. So you design the part. After now that you have finished to design the part, you need to slice the part. When you slice the part, you obtain now the G code. And when you have the G code, it's now that code that you put into the 3D printer for it to create the object. Now the 3D printer operates layer by layer. So it starts on the first layer, it print, and it goes to the second layer. So it's layer by layer. Now, why do we use the 3D printer? We use it for prototyping. We use it to manufacture low volume object. Like when we want to do compact prototyping, we use 3D printer to print some different parts. We use it to customize project. Like when you want to maybe print a protest for your hand, we need to take the dimension, the specific dimension for your hand, so that we can print it only for you. That is customization. We also use it for education, like we are doing right now. We use it in the medical industry. So the barrier of 3D printer, the advantage of using 3D printer is that we limit the risk of failure because we take it like step by step. It is step by step process, not like just going and manufacture. We print part by part. And the overview of the process is, first of all, we need to design the card, like to have the card of the object that we want to print. To do that, we use either SolidWorks, Inventor, or Fusion 360. Now, when we finish to design, we can obtain the STL file. Now, it's with that STL file that we are going to use a slicer software, whether Cura, Simplify 3D, or Prusa Slicer. Now, to transform the STL file to the G code. And now, when we have the G code, we can now directly print maybe using Fusion 3, Maker, or Ender Pro. But for this case, we are going to use Ender Pro because the other machine in the prototyping room are having some issue. So for that, let me just select one object so that I can take you through how we slice and so for this example, we are going to use Cura to slice the object. Here we are going to slice the design of the card. So for instance, this is the design of a vehicle, agricultural vehicle that we did using SolidWorks. So here you can make the design, the assembly and everything. And now later on you can now print part by part using the 3D printer. Actually we printed this vehicle, it is in the other home. So after this class, we can just go and get a part kit. So when we finish to design, like for instance, we can extract one part. Like this part. So when you finish to design it, you go and you save it as a STL file so that the slicer can understand it. If you said with another extension, I'm afraid that the slicer will not be, you will not be able to import the file in the slicer. So here you have the STL file. You can also save it as a stem file. with a step file and STL file, you can easily import it into the slicer. So when you finish to save it, you open now the slicer. So when you open this slicer like Quora, first of all here, like this is design that we are going to do our experiment with. So when you open the Quora, you can just go here, new project. You import the design by clicking on this button. You go up to the folder where your design is saved, and you select your design name. So this is the object. It is actually a dog. No, it is a pig that we are going to print. So this one has already been sliced. So you cannot modify the different parameter for it to print. It's already a G-code, as you can see here. G-code detail. So you can get the detail of this one. This is when, so you can slice the file, so you can design your part, slice it, and send maybe to a company for them to print with your specific parameter. And there they are not going to be able to modify the printing parameter. They can just be able to print it. But now when you want to send your own parameter, you should import either the STL file or the step file, like this one. So this is the STL file. So you can change the different position by using these different buttons. You can rotate the design by just clicking by this one. Just click on the axis. You can also throw the design, like linear movement of the design by highlighting this button. So when the design is out of the workspace, it's going to send you this, like the color is going to change because the design is outside the workspace here. And when the design is now in the workspace, the color is going to change and be layered. So when you position the part where in the workspace, you can now go to modify the printing parameter. So here you can put the layer height in millimeter. So depending also on the strength that you want your object to have, you may decide to put 0.2 or 0.1 or 0.4, depending on the strength that you want your material to have and also the nozzle that you are using to print. So you also have the possibility to have different height, layer height. At the beginning, you can have an initial layer height for the first layer, but the other layer above the first layer are going to have this value. So also here you can put the hole thickness. The hole thickness is like you are printing this front protector. This is the hole. So for this one, you can put a specific thickness. By default, it's 0.8 on for this printing, but you can change it to 0.4, 0.2, depending also on the strength that you want your object to have. So you also have the infill percentage here. So the infill percentage, as you can see on this model, is the percentage of like the pattern that is going to be inside the hole that you are that is going to be printed. So depending on the percentage of infill, you are going to have a specific like that pattern. From here you can see the pattern from this first picture is different. Like the pattern for this is different from this one. So this has a higher infill compared to this one, other one. So depending on the quantity of infill that you are going to put on the software, it's going to give you a specific like pattern. And even here you can define the type of pattern that you want, depending also of the quantity of material that you are going to use, the strength that you want the object to have, yeah, and also the printing time, because it also affects the printing time. Sometimes you may have an object that you want to be printed in 2 hours. So depending on the parameter, you are going to have a specific printing time. So here you can have a different inside pattern. You have the line, the crease, the cubic. So depending on the strength that you want your material to have, you are going to select a specific pattern. So here is about the material. Here you can select the printing temperature. Depending on the type of material that you are using, either ABS, PLA, TPU or PET, they have each of those materials has a specific printing temperature. For instance, this is for PLA, it's 200 degrees. But for ABS, it's between 230 degrees to 250 degrees. And when you are buying even filament, they are putting those information on the box, like this one, the PLA. Here is written 195 degrees to 200 degrees. So these are the printing temperature. So here we have two parts on the printing. We have the nozzle and we have the base. So you need to put a specific temperature for the nozzle, which is what we were talking about, the 200 and 195 degrees for PLA. And now for the filament to be able to stick on the base, the base need also to be hot. So the base need to have a specific temperature, and that information is also provided by the manufacturer. So for the PLA, it's between 60 degrees, 50 degrees to 60 degrees. And that temperature also affect the mechanical property of the part that you are going to print. So here you can also modify the speed of printing. As I was saying, you may have a design that you want it to be printed in 2 hours, and when you are slicing, it's giving you maybe 24 hours. So you need to tweak around this parameter to get maybe the time that you would like the part to be printed. And this also will affect the final strength of your material, because it's obvious if the lower the speed, the higher the precision, and also maybe the mechanical property depending on the shape of the object. The highest the speed, the highest the probability of error to occur on the printing, and also the part may not have the required strength that you would like it to have. So also here we have the cooling, which is very important, because when you are printing using ABS, it's sometimes advised to switch off the cooling system. Otherwise, you are going to have like the layer are not going to stick on one another. You are going to have kind of separation between maybe 2 or 3 layers depending on the part you are printing. But somewhere you are going to have separation if you switch on the cooling system. For PLA, you need to have the cooling system, but for ABS, it is not required to have a cooling system, or it is advised to lower the cooling system as much as possible. To lower the cooling system, here you have the speed of the fan. You can just reduce the speed of fan. You can put it maybe 20%, 10%, depending on what you want to have at the end, because this is kind of, you are going to try several times, and to be able to have what you really want, you may have to bring maybe 2 or 3 times. You lower, you see the outlook of the product, you lower, and you see, you lower and you try again. So here you can just tweak around this parameter to lower the speed of the cooling system. But for the BLA, it is required to have 100% fan. Now for the support, you may need to switch on this angle or not, depending on the part that you are going to print. For instance, if I were to print this part like this on the printer, I may not require to use support, because here all the parts are not in the space. They are together and they are on a specific axis. But now if I turn it on this way, I may require to add support so that I can be able to print this part, because the printer cannot print in the space. So depending on the position of the object in the workspace, and also the shape of the object, you may need to switch on the support or not. And you can even switch on the support for specific place. So you customize, like this place I'm going to put support here in this inner place, but here I'm not going to put support. So you can customize it depending on what you want to have at the end. So we have covered the all important parameters for like to set your first printing. So when you finish to set all the parameters, you can just come down here and slide.
Can you go up again and support how to customize it if they are trying to have an issue?
Which
On customizing the support, maybe the support thickness to be a little bit thin. Or
yeah, for the support, you click here. And when you click here, you are going to have other parameters to put in, like the thickness of the support and also the shape, like the structure of the support. So, for instance, here we only have one nozzle. But we have other printer in the other home where we have two nozzles. So we can use one nozzle for the support and another nozzle for to print the part. For that one, it will be easy to remove the support, even if they have the same percentage, like the infill percentage as the printing part. So for that one, you can just put maybe in the water, and even to choose the support for the printer which has two nozzles, you need to choose different material. Like for instance, if you want to print ABS with support, you can use ABS and PET. And when you finish to print, you just put the part in the water, and after some time you can just come and remove. It's going to dismantle itself. But when you are using such kind of printer with one nozzle, so that means the support is going to be the same material as the printed part. Now to remove it, to make it easy to remove, you need to lower the percentage of the support, so that the support is going to be weak, so that you can just remove it easily. If the support has the same percentage as the printed part, it's going to be difficult to remove it, and you can end up damaging the part that you have printed. Yeah. And for the two nozzle, the printer with two nozzle, you can specify it like here you want support, and this other part you don't want support. And to choose the printer, you can just come to this array. So here we have several printers. We have the Ichimeka, we have the Creative Index. So you can just go to Manage Printer and maybe select the type of printer that you want, that you are going to use to print. And selecting a specific type of printer will give you the dimension of the workstation, like the dimension of this plate. This is 220 centimeter for the X and Y axis, and 250 centimeter for the Z axis. So, and for the ender, the fusion, the Ichimeka is 200, 200, and 220. So 200 for the X and Y axis, and 220. So selecting a specific printer will give you the dimension of the workpiece. Like if I change this printer and I select maybe the Ichimeka, you will see that the dimension you see now the printed part is kind of small because we have changed coloration. We can't slice this one. This part is big for the Ichimeka, so you can't print it using the Ichimeka. And here you can see that we have another parameter. We have two nozzles. You have nozzle AA 0.4 and nozzle BB 0.4. So here you can now set the parameter for those different nozzles and select one nozzle for the support and another nozzle for the part that you want to make it. So for that one, with the creative, with the Ender Pro, we cannot do that. It is with the Ichimeka that we can do that. So maybe the next session we can try to do that, because the Ichimeka is not working now. So we are trying to fix it. So as I was saying, when you finish to enter all the parameters, you can just go down and slice the part. So now it's going to convert the drawing to the G-code. This always is kind of a gateway, like a translator, to take your code, like the design that you did on the STL or step file station, and convert it to the G-code. So here, now you can have the time that is going to take to print that part, 1 day and 22 hours, and also the amount of material that is going to use to print. So here it's going to use 440 grams, and it's going to be 147 meter of filament. So like this one, if you want to evaluate it as meter. So depending also of the availability of your material, you may tweak around this parameter to maybe reduce the quantity of material that we are going to use to print. Like this one is almost finished, and 440 gram. I don't think that that one is 440 grams. So if we leave it like this one, it's not going to finish the printing. So in order to reduce the quantity of material, we can maybe reduce the infill density. Here. So if we put it maybe 10% density, it's going to change the amount of material that we are going to use required to print that part, this part. So here, when we change from 20% to 10%, we move from 440 to 306 grams. And also the length of material change accordingly. Even the printing time also change because we reduce the pattern, the density of the pattern inside the pattern. So when we finish to slice, we save it on the flash disk. Or we can just save it in the SD card. But now, for this ender preview, there is no possibility to connect it to the online. But with the other printer, like the Fusion 3 and the Ultimaker, it is possible to directly print using the online connection. So maybe for the next session we are going to, if the printer is fixed, we can try to print using the Ultimaker so that you can see how to print using the internet and how to print using the USB key, and also how to customize the support. So when you insert the SD card and you slide the file, it's going to ask you to save in the SD card. Like this one, save to the removable. So you can just click on it, it's going to save in the SD card. Are you eject? Now you can just come here for us to so we put the SD card there. But in the printer, we can also set some few parameters, like the temperature. For the temperature, we can put like the PLA temperature, pre-PLA. It's going to put it automatically at 200 degrees and 60 degrees for the plate. And now, when you are printing, sometimes depending on where you are getting the material, you may face some problem with the material sticking on the base. Sometimes it may swap on the base during the printing. So it advises, depending on the type of material that you are going to use, to maybe use a tape to kind of put on the work base to improve the adhesion of the filament on the base. We can also use glue, or we can use blue tape, depending on the type of material that you are going to use to print. For ABS, it advised to use the blue tape. For PLA, we are using the masticon tape. Or we can also use the glue. And for the glue, you can get it in the library where they are selling book, and even in the supermarket. So when you set the printing temperature, you can also either set the printing temperature using the Silencious software or directly to using the printer. So with the Ender Pro, you just go to print from the SD card. And when you click on print from the SD card, you see the different design save in the SD card. You just select the one that you want to print and you start the printing. For it to start the printing, you need to wait for it to reach the different temperature, like 200 for the nozzle and 60 degree for the base. When you reach now, it's going to start the printing. You can also change the speed directly here. You go to the button 2, you change the printing speed, you change the temperature, the nozzle temperature and the bed temperature during the printing. So sometimes you can make an error when you are slicing the material and you realize that you put maybe 250 instead of 200. You can still change the temperature directly from the printer when it's printing. And sometimes you can even increase the temperature for it to stick on the base. So you use 200 degree and it's not sticking, you feel like it's kind of swapping. You can increase it to 210, 220 to see. Like right now it's not sticking. So you can just, it's not sticking because the pattern we are printing is very big. So it's taking all the whole workspace. And also one thing that we need to note that this workspace is not flat. It's not perfect, like flat perfectly. So sometimes we need to, because this printer is customizable, sometimes we need to add what we call a bed leveling sensor for it to do the leveling automatically before we start the printing. So for that we may have to do it in the next session, how to level the bed and to have a specific dimension, distance between the nozzle and the bed. Normally we use a sheet of paper to calibrate that, to level the bed, or we can do it automatically. It's all for this area. We may maybe go to the prototyping room for you to see the other things. Then eventually by coming back here, you will have done the first layer.